Okay, let us discuss Cramer's rule. So we have just discussed in the previous class that adjoint divided by the determinant of this. So this is the coefficient matrix, and prime means it is the transpose. So when you will find out the transpose, it will be adjoint matrix multiplied by, divided by the determinant of this and multiplied by the coefficient of that solution vectors. This gives the solution of the variable. So x1 is equal to b1 c11 plus b2 c21, so after transposition, plus b3 c31 divided by the determinant of that. So also for x2 and x3. Now, in case of Cramer's rule, the column associated with the variable be replaced by the solution vector b, and the new determinant be divided by the original determinant of the coefficient matrix to get the value of the variable. Now, so what we'll do from the coefficient matrix, we'll find out the determinant, original determinant. Then if we are to find out the value of x1, so the column associated with x1 will be replaced by the solution vector, b vector. Then we'll find out the determinant of that, and this new determinant divided by the original determinant will give the value of x1. Okay. Now, suppose this is the coefficient matrix, 3 by 3 matrix, and this is the new coefficient matrix after replacing the, say, column associated with x1 by the b vector. So 14, 22, 47, and others are 2, 3, 3, 5, 5, 7. So determinant of this is 3. So when we will find out the determinant, as I showed earlier, we will find that determinant is 3. So this determinant divided by the original determinant is equal to 1. So 3 divided by 3. So earlier we have got determinant 3. So 3 determinant by 3 is equal to 1. So x1, so x1 is equal to 1. Similarly, we can find that x2 is equal to 2 and x3 is equal to 3. So for x1, we have done this, and for x2, we'll keep as it is 1, 1, 1, and for this particular column 2, 3, 5 will be will replace by the b vector. Then we will find out the determinant of that, and that new determinant will be divided by the original determinant 3. So we will find that x2 is equal to 2. So similarly, x3 will be 3. So x1 will get x1 is equal to 1, x2 is equal to 2, x3 is equal to 3. So earlier also we got, and through Cramer's rule also we have got, say x1 is equal to 1, x2 is equal to 2, x3 is equal to 3. And putting these values, if we see the value of the equations, then we will find that all the 3 equations are satisfied. It is, the values will be your 14, 22, 44, as I said earlier, it is the b vectors. Now there are properties of inverse matrix. 14, 22, 47. This is value of B factors. All will be satisfied. Okay. Properties of inverse matrix. Now, AB inverse. So, if we multiply matrix A by matrix B, what the result we will get if we inverse it, this is equal to inverse of B matrix into inverse of A matrix. Then for AB into B inverse into A inverse is equal to A into BB inverse. So first we will multiply B matrix by inverse matrix of B. What result will get multiplied by A. Then again it will be multiplied by A inverse. So this gives A into identity matrix A inverse is equal to A inverse is equal to identity matrix. So this needs some homeworks. So we can take any matrix, assuming any matrix A, B, then we can find out this. Then B inverse into A inverse, what result we will get multiplied by the result of A into B is equal to identity matrix. Then C, inverse of an inverse is the original matrix. So A inverse, we have the matrix A inverse, then into A inverse, okay, and inverse of that, inverse of inverse multiplied by A inverse is equal to identity matrix. Then A into A inverse into inverse A inverse, what we will get again inverse is equal to A into identity matrix. Then again identity matrix multiplied by A inverse of again inverse of that, inverse of A inverse is equal to A. Then A inverse again inverse is equal to A. Then D, inverse of transpose equals to transpose of the inverse. Inverse of transpose equals the transpose of the inverse. A into A inverse is equal to identity matrix. Then A inverse into transpose of A is equal to identity matrix. Then A inverse transpose of that, then A transpose into A transpose inverse is equal to A transpose inverse. Again A inverse transpose of that is equal to A transpose inverse of that. They are equal. So these are some of the properties of the inverse matrix which we can do some homework. Finally, A inverse, determinant of A inverse is equal to identity matrix divided by determinant of A. So determinant of AB is equal to determinant of A into determinant of B. Again, A inverse A is equal to I, and determinant of I is equal to 1. Then determinant of A inverse A is equal to determinant of A inverse into determinant of A. Again, determinant of A inverse is equal to identity matrix divided by determinant of A. So these are some of the important properties of inverse matrix. So we can prove it with the help of some, say taking some square matrix, imaginary square matrix, and you can prove it. Say A is equal to this much and B is equal to this matrix. then multiply, take inverse like that. It will be homework and it will be easier to understand. So with this, we have completed the matrix inversion, and thank you very much for watching, and please share and subscribe. Okay, thank you very much.